Welcome to this TopoDOT presentation. Today I'm going to be discussing how to leverage point cloud project data for effective as-built surveys using TopoDOT. And this presentation is for Lidar CANEX 2024. My name is Jennifer Triana. I'm Business Development Director for TopoDOT. Here's my contact information. There will be another slide with my information at the end if you don't get it by now. Just a little bit about TopoDOT, who we are. We're a software company in Florida. We have been developing software for over 15 years, always around the LiDAR industry. We come from the hardware side of the industry, so we are developing software to solve problems around LiDAR specifically. Understanding the limitations and sources of error of LiDAR has led us to build better software for these applications. And right now, we are a pretty successful company with a lot of clients in the Americas, including a lot in Canada, that mostly deliver deliverables in the transportation industry, specifically around utilities, mapping of infrastructure, civil infrastructure, construction, oil and gas, and more. In a nutshell, TopoDOT is an application for the Bentley environment that allows you to bring in point cloud data, calibrated imagery, orthophotos, GPS information, and all related information to build your 3D model, 2D model of these as-built conditions. And we try to do it in the most automatic yet most controlled manner, giving you the efficiency to create and verify at the same time. We'll discuss a little bit more about the applications and the types of features you can extract with TopoDOT. So if you're new to TopoDOT, know that you can apply it almost to every kind of application that you might scan for, including applications that are purely engineering, like in data analysis and reporting, which I can speak for about those a little bit more. So today I'm going to do a brief introduction on TopoDOT and just kind of like what is the difference between TopoDOT and any other application in the geospatial market that you might have seen out there. And then I'll go into some more details about what's new, what's the latest information from TopoDOT if you're already familiar with TopoDOT and you just want to learn more about the new stuff. So first of all, the TopoDOT platform pretty much solves this area in the green. Oops, this area in green. Meaning there is a process before you come into TopoDOT that TopoDOT does not replace. And this process is basically data collection and data alignment. So moving data is still part of the process that we recommend be or happen at the system level. Nobody knows how the system behaves better than the software that comes with it. Other than that, you don't have to worry about TopoDOT, about the data, modifying the data, cleaning it up, removing noise, or any of that. As long as the data is in the right place, then you can come into TopoDOT and we'll help you with the max process. With the max process is manage, assess, extract. And we give you all of these tools to not only be more efficient about your process, but also to produce a high quality deliverable. So in the manage portion, we help you manage your data, despite of size, despite of source. If you want to host it on the web, how do you share it? How do you visualize it? How do you, deploy it? The assessment tools are here to help you qualify the quality of your data and ensure that it's going to meet your project requirements. In the extraction portion, we will help you do all the feature extraction and data analysis needed. And then you have a third qualification step that assesses the model against the point cloud, giving you assurance throughout the process to eventually deliver whatever it is that you're trying to export, a report, a AutoCAD file, a GIS file, etc. So this process will allow you to be successful at the feature extraction process from your point cloud data. It's the key to unlock the power of your data. So let's talk about some of the differences between TopoDOT and other products out there. Let's start with the way that TopoDOT visualizes data. Everybody kind of keeps throwing AI at software, but AI is such a broad term that it's really hard to understand what parts of AI are really being used in software and what is new, right? We have been using AI from the very beginning. One form of AI is basically computer vision, is how to visualize the point cloud. And that is what we call signature-based approach. So in most software out there, you probably need to remove vegetation, noise from vehicles, people, just any kind of noise to produce a surface model, because you're producing a surface model out of the cleaned up data. In TopoDOT, that's not needed. And it's because we focus on what is it that we're extracting, what makes that feature singular and unique, that we can concentrate on that particular set of factors and ignore noise. So in this case, we're creating road cross sections from the data. And as you can see, the points on the ground are extracted despite of the noise from vehicles created across the road. And that's because we're looking for the singularity on the road. This also allows us to concentrate on what's important about the road in this case. So for this area that is heavily rutted, you can see that we can pick up on the nuances of change. Where are the hills and valleys? And this can produce a more optimized surface model. And this is especially useful for those who are going to be delivering in Civil 3D, which requires maybe fewer points or nodes on that model. And the way to do this is not by picking points out of the point cloud. Picking points out of the point cloud, you could be just randomizing the selection of your points, producing more error because you are not accounting for this random noise that every LiDAR equipment or data produced from LiDAR or even photogrammetry has. So it's this thickness, the thickness of your data, right? Like your point cloud is not defined by one point, but a series of points. And when you strip your point cloud to one point that represents an area, how do you know it's not picking up the top or the bottom of that noise section or the noise difference? Instead, in TopoDOT, what we do is we look at the point cloud and identify the median of the data noise, weighing all the changes in noise level, and we can pick up that median immediately without having to strip the data. So what this does, it reduces that randomness noise, and that is a normal error source for any LiDAR platform. Even the cleanest LiDAR out there has some kind of thickness. So when you randomize the selection, you can end up with a spiky surface, and in order to clean up those spikes or errors, you could smooth it out, but then you sacrifice small breaks like an edge of pavement, an edge of shoulder, breaks that are smaller than the noise level that you're trying to eradicate. But when you do the statistical analysis of the data, you don't have to worry about trying to smooth it later. It's already smooth on the get-go, and you can include that those break lines, the small break lines, are going to be a lot more visible, cleaner, and you don't have to smooth those areas out. So this is a difference in one example, in this case, surface modeling. And this also translates into what if my data is not perfect? If you're trying to pick up points out of the point cloud, what happens when you have gaps or misalignment or noise over your data, meaning you don't have obstruction over your actual features? Well, because TopoDOT doesn't depend on having a point in the point cloud, you can actually build better models on areas that are noisy, with gaps, or with obstruction. And this model is vectorized, and the vectors are used to create the surface model, producing therefore a cleaner surface model, even from the noisiest data. And this is all also achievable based on a balance between automation and quality. Everybody wants to have the automation in their extraction, but a few people understand that automation is driven by quality. So if your data has the highest quality, then automation is possible. The more perfect your data is, quote unquote, the cleaner your algorithm is going to perform. But we know that that's not the way of the world. You're going to have nuances, imperfections, and issues. So what TopoDOT does here is balance those out by finding a signature on the data. What is common? What is singular about this feature that we're extracting? In this case, this curve is the profile of the curve, right? But if it tilts, if it changes, if it gets shallower in places, or if it changes in profile, you have the ability to qualify those results at every step. And by being able to qualify the results, you can assure that the automatic function completed the process properly, or that it was all right. And that way you don't have to go back and figure out where the algorithm made a mistake, right? So this process is what's called semi-automatic, meaning you have an automation, but then you have the quality assurance that a person can attest for, assess, and therefore you're done. You don't have to go back and figure out any issues. You can move on into the next segment. So it makes it much more efficient. Moreover, we can provide you with tools that are going to make your breakline extraction a lot faster. So let's say you have a lot of features that happen constantly between your breaklines, like ramps, inlets, driveways. You can make a template of it. It'll take you 5 minutes to create this template with the line work in the colors, in the levels, with the dimensions as necessary. And then create a profile, or a smart cell in this case, that you can place and adjust to current conditions within 30 seconds. So that 5-minute process that took you to create that line work will be reduced to 30 seconds to place it. And it's going to look uniform across your drawing and across multiple users. So ideas like these will allow your feature extraction to be more efficient. And it might not seem like it's fully automatic, like if you're writing a script and letting it run, but because you're driving it and you're qualifying it, it's a lot more efficient, and you have control over the process. In order to so one other thing that I wanted to mention here is that because TopoDOT is system neutral, as long as it's a point cloud, you can bring it into TopoDOT and apply the tools across different platforms. So let's say that you have mobile data, or drone data, or tripod-based, airborne. It doesn't matter. As long as it's a point cloud, it's right location. You can even blend data together, so data fusion projects. In this example, we have some mobile data on the rail area, and on the blind spot, of the mobile, we have the drone data. Because this is using the same datum, it was able to be placed simultaneously or in the same place and process as one. TopoDOT can do that. TopoDOT can run the same tools that you would run in mobile in drone, just change maybe some settings. And this way you can diversify in the platforms chosen for feature extraction and not have to stick with different softwares for different platforms or different brands. You can just pretty much bring all your point cloud data into one platform and create CAD elements. We have tools for almost anything that you might need. Topographic corridors for road, rail, bridges, tunnels, as-built conditions for ALTA surveys, indoor applications. But we also have some tools for data analysis, and these are very popular in a lot of projects that have helped Canadian customers in particular. So rail, especially with tunnels, cross-slope analysis, and road pavement conditions. All of these tools are included in the TopoDOT platform. There are no different modules or different products. Everything is part of TopoDOT. So knowing that you have the ability to create some of these reporting and monitoring capabilities allows you to diversify the use of point clouds beyond just the as-built condition modeling. And lately we've seen a lot of uptake in the utility market. So whether as for power or communications, just being able to map corridors and do analysis on power corridors for encroachment analysis, clearances, attachment, detection, asset identification, extraction, you name it. There is a lot of applications. There are a lot of applications in this regard. All right, so talking about what's new, if you're already a TopoDOT user, just kind of want to brief you on some of the new tools out here. We have a new way to vectorize sidewalks, and this new tool actually uses the center of the slab on the sidewalk to identify the slope of the slab. Because a lot of times we have gaps, like as you can see, the blind spot behind the grass, or we have overgrown grass over the sidewalk, so it's difficult to pick the actual edge. But with this tool, you can actually use the slab, the center of the slab, to create that. But it's more versatile than that. It actually identifies previously created line work and it attaches to it seamlessly. It can help you build complex line work types by identifying how to break it up, and it also allows you to qualify the results. This tool can be a companion tool to other analysis tools. So if you're doing, for example, ADA compliance on sidewalks, you can actually use this to detect changes in the slabs and then run a surface analysis function. So as you can see here, it creates that additional line work and it attaches to the endpoint seamlessly. So this is a new tool and it's really been a success for a lot of our users that are currently using it. In our last iteration, our last update last year, we showcased these new AI ground extraction. So we've always been able to create surface models without cleanup of the data, but this revamping of the tool incremented the validation of the true points through AI of these areas of low density, maybe areas where the ground is less dense, and the areas where it changes in slope changes, especially in steep areas, producing a lot of natural breaks just from this tool, which allows you to create a surface model that is very clean and right, and you don't have to produce a lot of natural break lines after the fact. So is in some of the tests that some of our clients have done, especially for volume calculation on queries or retention ponds, it can reduce the production process from 4 to 5 days down to a few hours or less than a day, because you need fewer natural break lines that would have to have made manually. Another cool tool that is relatively new is this moving object classification process. So we've added a ton of new classification tools. Classification has never been necessary for doing feature extraction, but it's certainly useful, especially if you're going to make a video or a presentation and you want to reduce or remove all these vehicles or people that are constantly moving. And we have another process that we're going to show you later. So this process is very quick and immediate, and it can separate the moving objects from everything else. Moreover, we have some of brush capabilities for classification, just making it easier to classify. In the analysis and classification tools, we have a new encroachment clearance reporting capability. So this tool has existed, it's been in existence before, where we can analyze obstruction on rail corridors based on a cart or shape, right? But the capability to report where clash detection is happening has been improved in this sheet extraction process, and is a very visual and very easy to represent that clash detection. We also have some classification tools for identifying and reporting changes against a plane that help evaluate changes, detect changes along a plane, or visualization of layers of movement. And these can also be reported in a very easy and clean way. So here we're seeing how this wall is deviating from the plane or the path, and by how much, and you can see that it's turning red because it's outside the range, so we can show those changes. A lot of our tools just get revamped and get much better over time, but in this case, for example, this clearance from slice is great for identifying lowest point across a road on power lines or signs or traffic lights, just to quickly identify low point against the ground. Typically, we used to have to go line by line, but now we can apply it to almost everything under that cross section. Like I said, you can apply the sidewalk analysis. It's similar to what we do with the roads for ADA compliance. It's the same tool that we use on roads, just applying different parameters. Just like you can apply this tool for a runway, for example, where the road is way wider. There is a new tunnel variance tool. This is really cool. This is to compare design against actual conditions, and this will show you where you might have potential issues for clearance or to detect variances over time. So like caving, tunnels, and things of that nature. And this one is one that is actively being worked on. It's called change detection. We're specifically applying it here to the utility market, where you might have survey pre and post, at some time difference, and to detect any features that might have been changed or might have been out of place. So for example, if there is a catastrophe, you want to know if anything moved. receiving feedback for, and identifying whether it can be improved and how it can maybe solve questions in real world examples. So this is actually a project from one of our customers in the Ontario region. All right. So like I said, you can apply it to utility mapping very efficiently to detect new vegetation, new equipment, or changes in that equipment. All right. Just to finalize this, there is a companion tool called TopoShare that allows you to share this information efficiently across your organization or to other stakeholders that don't use TopoDOT, and really take it to another level. So you can apply all of this information to a web dashboard, and anybody involved can visualize point cloud, line work, imagery, and request further information or make small measurements on the data, and therefore have some sense of the project in a very visual manner, but not necessarily need to learn how to operate TopoDOT or learn how to use point clouds at all. So it's a very robust type of process that can be implemented from the back end when you're extracting the data all the way through into delivering and communications of the project. So if you want to learn more about TopoShare as part of TopoDOT, you can let me know. And that's it. So please, if you have any questions, I'll be here to answer any questions. Otherwise, you can always contact me. Here's my contact information, and I'll be happy to answer any questions. Thank you.
We do have a couple of questions in the chat. I'll read this one from Andrea, and I think it was related to your, I believe, a new tool that is coming out for the ground classification. Does the Bare Earth tool extraction work with any point cloud? Lidar, structures for motion, multi-beam point clouds?
Yes, as long as it's a point cloud, you can use this tool for ground extraction. So different data sources have different quality measures, right? Like some are maybe noisier, some photogrammetry data might not have a lot of information underneath vegetation. But it doesn't matter. The tool will be able to pick as much as possible from the existent information.
Okay. No, it looked very impressive, and you pointed out, it even handles those quick changes in terrain, which often will cause algorithms to misclassify the ground, thinking that it's beyond a variance threshold and so on.
And moreover, just being able to pick those changes or the breakpoints where those changes are happening reduces the amount of manual break lines that you have to extract.
Okay. Are there many parameters that a user has to put in to sort of set the algorithm going?
No, the tool basically is very user friendly because it only asks you to sample what's typical on the data. So it just tells you find a spot that best represents the data, and the tool will identify the best slope changes. So that's all the user really has to do.
I especially liked your dashboard and the idea of being able to put out I'm assuming kind of either a compressed or a reduced data set that perhaps non-experts of TopoDOT can make use of. I think that's a real smart thing to go do, and I can see more and more companies wanting to do that for people, to expose people to the data, but yet not require them to have a great deal of training in order to interact with the data.
It is meant to be a communication tool for those who just want to be able to get the additional value from the data. So Typically, data is collected for X and Y purposes, but then it gets shelved, and finding this data later on, it's definitely an issue for a lot of people that have stacks of hard drives somewhere, right? So this way, we're just trying to promote going beyond the initial project to extend the value of the data and to share these and communicate to those parties that don't really understand LiDAR to know what's possible with the information and maybe get more traction for the utilization of this data.
You bring up a good point that I didn't really think about with the idea of, just sort of tracking your data, because if an organization is continually or annually collecting data, before long, didn't we collect it here? What year was that? Just that whole idea of cataloging and being able to quickly access, did we cover this particular area that we have a new project for or something? And I guess that also folds in nicely perhaps with your change detection tool that you're now making use of.
Yes. So the ability to just go beyond the original project really is going to bring back all this data that we've collected over the years that we can still use to detect changes, verify information, monitor surfaces, etc. So it's definitely the goal is to just keep on digging value out of that information. So I'm glad that you can see the use of the dashboard beyond what the geomatics team, what the specialists will do with it.
Yes, no, I think, and it looked very, not too intimidating and fairly responsive.
Indeed, indeed. It can be overwhelming for a lot of people, just the 3D aspect of point clouds. So we try to make it as simple as possible because it's also running on the web. So when you start doing a lot of 3D, let's say, manipulation, not only it's very it consumes a lot of power. It gets clunky. So this is very light, very clean, very easy, and so we're just trying to promote communication and just making it fast. It's part of that key.
Yes. Well, and you obviously are, have succeeded there very well. Just sort of a technical question, and maybe this is proprietary information, but are you using a proprietary format that you've developed to store the LiDAR to make it so responsive on the web, or are you using a standard that's out there already?
No, actually, practically, TopoShare is not even the storage. So you use your own storage options. So you could use, standard Amazon, Azure, Oracle, whatever you want to choose for your storage. TopoShare, all it does is just the catalog of your information. So it knows how to retrieve it and how to share it and how to use it within the TopoDOT platform for feature extraction.
Okay, very good. One last question from me. Are you starting to break into the Canadian market? Do you have many Canadian users of your software?
We have had many users for from the very beginning, both on all over Canada, but we have seen maybe beyond transportation a lot more uptake into oil and gas applications, into pavement condition applications that I've seen a lot of customers that have these projects where they have to monitor town roads over every 2 years, and so this has been a great opportunity especially in the Canadian market to break through, and we have clients from government agencies, provinces, municipalities, cities, all the way to large engineering and surveying and mapping constructions.
Very good. And I know Alex, who will be speaking in a couple of sessions from now, those folks make use of your software for their reality capture environment. When you mentioned about pavement conditions, I was, living in rural Nova Scotia in the spring. There's no shortage of potholes and so forth. So it would
Yes.
be a great application to direct our government agencies where our roads need to be repaired and fixed up.
Yeah. No, I really hope that for the next iteration of CANEX, I could invite one of my clients up in Canada to just speak for, what these type of tools are doing, not only just in the geomatics world, but also how is this promoting better, let's say, budgeting for towns to
Hmm.
understand where to put their resources and to how inexpensive it is to do it with LiDAR versus anything else.
No, that's a great point. Great point. Always nice to hear from the users of your software, and I'm sure you get
Back.
lots of good feedback that help direct your development and so on.
Indeed. No, and having clients like Alex speak about their experience, brings that actual like case study, live, real world
Hmm.
understanding of how the tools behave. I can only speak for how it does it, but it's amazing to see the type of things that they do. Um, Tim, I see a couple of other questions, and I just wanted to mention
Oh,
that yes, you
yes.
can get a trial. So if anybody's interested in seeing how the data is how the tools are performing on your data, please contact me, and I can not only show you what's possible on your own data, but uh, give you the tools for you to test it out.
Thank you. I'm sorry I missed that, and I had the chat open, but not the other one. And do you see this other one? Can you please comment on the performance of handling big point clouds? Also, if TopoDOT has functionalities for industrial applications such as piping or pipelines.
Correct. Yes. So the great thing about TopoDOT that makes it system agnostic is that you're going to have data from all sources, especially if it's a kinematic system like a mobile system, drone, or airborne. You're probably going to be collecting gigabytes of data. So TopoDot has a process that takes you from managing your data, so not only storing it, but looks at project is, there is a way. You don't have to have a supercomputer either. This is something a concern of a lot of people that I have to have, this
Mhm.
amazing machine in order to run point clouds. No, I run it from my laptop. You just need to be conscious about your file size, how you break down your data into manageable segments. And this is a good practice for cloud storage. And yes, we do have tools for oil and gas for piping. So all the way from like infrastructure, like typical um, pipes to like on like huge refinery type of infrastructure to just kind of like pipes that you map over, terrain. And if there might not be structurally, you know, um, even. So we do have tools for that. It's just hard to show every tool. But the cool thing about this too is that you get everything with TopoDOT. So you get all your topography tools, your piping tools, your power line tools, your data assessment tools. So whatever application you see that you can explore, you already have those tools there.
So in the case if somebody took, say, a tripod mounted scanner into an industrial site where there were lots of pipes and other equipment and so forth, does your software handle that in terms of identifying this is a pipe and now let's track it and perhaps make a rivet model or
Yeah.
things like that? Yes. Great.
So TopoDOT will give you the model of a feature. So if you want to just kind of model it and maybe compare against the sign, compare against its existing conditions, you're in a CAD platform, so you can do all that too.
Very good. We have another question. Is it possible to use your technology in collecting underground structures?
Yes. So if your bathymetry data can be turned into a point cloud, you can certainly use it in TopoDOT. We have many projects where you do bridge scouring, underground mapping. We're talking about water, right? Now, if it's something like a tunnel or a manhole or something like that that can be scanned, perfectly fine. We could do that. We have tools for tunnels, for manhole, for wires, but not ground penetration radar. That's a whole nother science that is not at this moment there are some people that are trying to turn that information into point clouds, but until we have maybe better definition or signatures on the data, there is not much we could do about that.
But say if somebody flew a drone or some other scanning system in an underground mine, as an example, and so forth, I guess from TopoDOT's perspective, a point cloud is a point cloud, and you can work with it and extract features, sort of irregardless of the source and whether it's above or below ground. Would that be true?
For any underground mapping that's done with point clouds, we have tools for rail, for tunnels, for especially for the type of applications that you have in tunnels. Maybe you're doing monitoring, see if something's caving. Maybe you're looking for clash detection, So there are a ton of tools that are applied to underground mapping.
As usual, a very nice presentation, very informative.
Thank you.
Great to see the new advancements.